To sketch a rational curve for the given function, we need to find the coordinates of the x and y intercepts. When y equals 0, the numerator, 5x minus 2, is 0. Thus, x is 2 over 5. When x is 0, y equals negative 1. So, the curve crosses the x-axis at 2 over 5 and the y-axis at negative 1. To determine the horizontal asymptote, we divide the coefficient of x in the numerator by the coefficient of x in the denominator, which gives 5 over 3. For the vertical asymptote, x cannot be negative 2 over 3. We draw the horizontal and vertical asymptotes and plot the x and y intercepts. The graph is a hyperbola consisting of two branches, one in the top right quadrant and the other in the bottom left quadrant. It is given that the gradient of the curve at point A is parallel to the line 4y minus x equals 7. The equation of the line is equivalent to y equals 1/4 x plus 7 over 4. The gradient of this line is 1 over 4, which is the same as the gradient of the curve at A. The gradient of the curve can be obtained by differentiating the expression. Using the quotient rule, the numerator becomes 3x plus 2 times 5 minus 5x minus 2 times 3, and the denominator is 3x plus 2 squared. Simplifying the numerator gives 16. 3x plus 2 squared equals 64. Taking the square root of both sides, we find 3x plus 2 equals plus or minus 8. The two possible values of x are 2 or negative 10 over 3. The problem states that the normal to the curve at A intersects the x-axis at point D, where x is positive, and also intersects the y-axis at point E. We need to find the length of DE. The gradient of the normal at A is negative 4, which is the negative reciprocal of the gradient of the tangent. We will check which value of x to take. Substituting x equals 2 into the curve equation gives y equals 1. When x equals negative 10 over 3, y is 7 over 3. Thus, we have two possible points for A. We form the equation of the normal using the point 2, 1 and gradient negative 4. To find the x-intercept, we substitute y equals 0, and we get x equals 9 over 4. When x equals 0, we find y equals 9. This is the y-intercept. Next, we check the other point, negative 10 over 3, 7 over 3. Using these values and gradient negative 4, we form the equation of the line. Substituting y equals 0 into the line equation gives x equals negative 11 over 4. Since the normal line crosses the positive x-axis, d is 9 over 4, 0, and e is 0, 9. The length de squared equals 9 over 4 squared plus 9 squared. Taking the square root of both sides, we get 9 root 17 over 4, which is the exact length between points D and E.